In question 7, we're told a circle with centre C minus 3, 2 has equation x squared plus y squared plus 6x minus 4y is equal to 12. In part A for 3 marks, we need to find the y coordinates of the point where the circle crosses the y-axis. It will cross the y-axis when x is equal to 0. So just subbing this in, we're going to have 0 plus y squared plus 0 minus 4y is equal to 12. We can rearrange this. We have a quadratic in y squared minus 4y minus 12 is equal to 0. That looks like it'll factor. Y minus 6 multiplied by y plus 2 is equal to 0. So y is equal to 6 or y is equal to minus 2. Therefore, what we're going to have is the point 0, 6 and the point now 0, minus 2. So 3 marks for the first part. In part B, we're asked to find the radius of a circle. The question carries 3 marks. A couple of different approaches. In general, we can write the equation of a circle as x minus a all squared plus y minus b all squared is equal to r squared, where r is the radius. So let's look at this. I can go ahead and complete the square. I've got x plus 3 all squared minus 9 plus then I'll have y minus 2 all squared minus 4 is equal to 12. So this gives us now our circle, and we know the centre is minus 3, 2. We've got x plus 3 all squared, y minus 2 all squared, adding the 4 and adding the 9 to both sides, that's going to give me 25. So we can say that r squared is equal to 25, and the radius will be the positive root of 25, which gives us 5. In part C, the first part, it says here now, the point P 2, 1 lies outside the circle. Part 1, for 2 marks, find the length of CP, given your answer in the form root n, where n is an integer. In the second part, again for 2 marks, we're told the point Q lies on the circle so that PQ is a tangent to the circle. We're asked to find the length of PQ. What I'm going to do is a quick sketch. We certainly don't need one, but it might help us out. What I'm going to have is the centre, and we know that the centre is minus 3, 2. So let's go ahead and put this here. So C, we've got minus 3, 2. Let's put the point here, P. It doesn't matter that this is not massively accurate, and we've got 2, 5. All I'm going to do at this point right here is use the distance formula, or if you like, Pythagoras. We're looking at this length right here. So what we can say then is CP will be equal now to the square root of minus 3 minus 2, which we need to square. Then we're going to have now the 2 minus 5, and we need to square that. So 2 minus 5, which we need to square. So we're going to have now, this is going to give me minus 5 squared is 25. That will give me minus 3, so that will be plus 9. So we can say now that this is the root of 34, therefore now n is 34. Okay, let's move on to the next part, and I'm going to use the diagram again here. We've got this point Q, and it lies on the circle such that PQ is a tangent. Now we've got a couple of different choices here, and I'll just show you what we can do with this. Let's just go ahead and do that. We could have it just here, or we could have it just here. It really doesn't matter for this particular question. So if we put now the point here, this is going to be Q, this is going to be Q if we like. I'm going to choose either one of these. Now let's just consider what we've got. We know that the radius of this circle is going to be 5 units. If I put this on, what we've got now is the tangent radius theorem, which tells me that this is a right angle and this is a right angle. I know this length is 5, and I know that this is the root of 34. So all we've got here is 5, 5 and root 34, and we can simply use Pythagoras. So if I just sketch this up, what we've got, a quick sketch, and again, it doesn't have to be massively accurate. It just gives us some idea of what's going on. So what we've got here is the right angle. We've got now that the hypotenuse just here is the root of 34. So let's go ahead and put this on. And then we've got the radius, which is 5. So using Pythagoras, a squared plus b squared is equal to c squared. We can say, now calling this one a, we can say that a squared plus 25 is equal to now c squared, which is 34. So a squared will be equal now to 9. So a will be equal to plus or minus 3. Therefore, we can say now that it will be equal to 3. So we've got now 3 units. So we can say that PQ will be equal to 3. You don't need to show all this working. I've just done a quick sketch as it will help out with some more challenging questions like this, because in some questions we might be asked to find the possible positions of Q given other information. All I've done is shown that if we have P, the centre, and Q, we've got tangents. They create now a right angle. We've got the hypotenuse of this triangle, and we can just work from there.